loud voice?
No, no, it's okay. Just this.
Yeah? Okay. Yeah. Okay, thank you. Thank you for giving opportunity to talk this. My talk title is Winding Number with Arbitrary Integer Value in Cubic String Field Theory. My study is about cubic string field theory is open bosonic string field theory. This is action. And the psi is string field, argument is string configuration, and the QV is VLST charge, and the star product and the integral is satisfies following property. This 1, 2, 3, 4, 5. And string field is grade G, ghost number. And this action is invariant under the infinitesimal gauge transformation, this. And this is in Witten paper. He write the reason for this action, this paper, non-commutative geometry and string field. Like Yang-Mills, if we consider F star F, the variation of P and the arbitrary variation of A is a gauge field, string field, and the F is a curvature. And the arbitrary variation is 0. Since no analog of raising and lowering indices within these axioms, he considers this additive. Associative star product is natural for open string, non-commutative, and this associative product. So these axioms, there is no analog of Yang-Mills, like Yang-Mills action. Then he considers Chern-Simons three form is not always invariant under the large gauge transformation, but might suffer from global anomaly. So he considered this action. Higher Chern-Simons form is vanished automatically due to the ghost number. So this is cubic string field theory candidate. And the Chern-Simons theory, under the finite, as I mentioned, under the finite gauge transformation, A is gauge field by a gauge group valued function gx. Chern-Simons action transformed this quantity, and g is given by this. This is called winding number because winding number of mapping gx from the manifold M to the gauge group. Due to this property, k is the integer, and energy can be rewritten as the integration of total derivative, like this, which is given by the Lie algebra valued function phi x. This is not a direct function of g, but gx equal exponential I phi x sigma, for example, SU2, Pauli matrix. N is almost vanished because of total derivative. This manifold is compact, so almost vanish because of total derivative. However, we can evaluate N as the integration with boundary delta M, being the singular point phi x. And we obtain the integer value. And this form is manifest the topological nature of winding number. Then, same consideration. Let us consider in same way in cubic string field theory. Under the finite gauge transformation, cubic string field theory's action is transforms this and is given by this form. And U star QV U inverse, but here from hereafter I omit star product. And this quantity is proportional to energy of static pure gauge form solution. So natural question is that taking this n, taking quantized value, if so, what is n counting? Can be rewritten in the form of the total integration of total derivative, corresponding integration of QB exact. And this open string coupling we quantized as the case of the K level in Chern-Simons theory. What the manifold M and its boundary delta M are, what is compact, etc. So in this study, we pursue motivated the similarity between Chern-Simons theory and cubic string field theory. We pursue the possibility that N, this quantity, is interpreted as a kind of binding number in CSFT, which is quantized to integer value. Through this quantity, we wish to find fruitful structure of SFT, which we still do not know. And forward to this, today's talk is N can be written as this form, and this form, as mentioned above in Chern-Simons theory, this is a singular form. So singularity and appropriate regularization. And the construction of binding number with arbitrary integer value. And before finishing, some comment and the conclusion. In previous paper, I was discuss about this for simple string field, and the result is cannot avoid anomaly. So therefore, cal n could only take plus minus 1, plus minus 2. But today is more general case I consider. Before start talk, I prepare KBC string field. Move on. This is upper half plane. Move on to a frame where the multiplication of strings, star product, it becomes easy. This coordinate transform by arctangent upper half plane. And we introduce three quantities written as K, B, and C, which satisfy the following algebra. And B is anti-ghost, line integral of anti-ghost, and C is ghost insertion, and K is given by line integral of solid energy tensor. This. And vacuum transformed as exponential minus K in this convention. Like this state. So exponent K is line integral from here to here. K generates the strip, this world sheet. So exponential minus Tk is equal to semi-infinite strip. I omit the half, but a semi-infinite strip with T. And the space is constructed K, B, and C is not depend on detail of BCFT, universal. Now, there are several solutions constructed in this space. So I limit this KBC space. And the general string field U, we will consider UQU inverse. So general string field U, this is ghost number 0 field written in KBC is like this. This is F, small f, and G, and large G is an arbitrary function of K. And the GK and the AIJ, A is here. AIJ is given by this. G is, So So Aij is defined as this, and the G is defined as 1 minus trace. And I is runs over 1 from 1 to large M. And in previous paper, we consider only in the case of M equal 1. And all Aij are not independent. 2m minus 1 degree of freedom is only 2m minus 1 degree of freedom independent. For example, in the case of large M equals 3, this 5 is independent. For example, A2, 3 is written by A2 to A1, 3, and A1, 2 by definition. And the G is given by this trace part. Then UQU inverse right psi is given by this form. And this is psi is goes to number 1. And the choosing function large G and Aij determines psi. For this psi, we introduce psi u carrying a parameter u. U is 0 from 0 to 1, and interpolating psi and 0. We assume a boundary condition u at u equal 1, psi u equal psi. This is a non-perturbative solution, and u equals 0, psi is 0. This is perturbative trivial vacuum. So then we can show curly n can be written as like this. So this is it is okay integral in here. So this is the integration of QB exactness form. Indeed, we can choose psi u like this. And this form is jump at u equal 1. U is not 1, psi u at perturbative vacuum, but u equal 1 jump to non-perturbative vacuum. So this form, QA, almost vanished because of BRST exactness. However, QA has a singularity at k equals 0. K is KBC algebra K. So like QA is a delta function, and at u is not equal 1, this is regular, so safety 0. But u equal 1, this is not safe. This is singular. And as mentioned, n proportional to energy of this solution. So if we choose the psi is non-perturbative vacuum, n is non-zero. So left-hand side and both right-hand side, for consistency of both sides, it seems necessary to introduce a regularization to QA, which extracts and at the same time regularizes the divergent contribution of the zero eigenvalue of K. And we adapt regularization at K equals 0 as K to K plus epsilon, and then obtain the expected value, which is obtained by direct calculation of LHS. So we adapt K plus epsilon regularization. Since regularization breaks the KBC algebra, psi is no longer pure gauge, and the equation of motion is broken in order epsilon. Here, argument, so it is non-trivial whether EOM satisfies in the limit epsilon to 0. This is EOM, and this is a variation of field. We examine the validity of the EOM only for O equal psi A, psi itself. it is necessary to show the equivalence between energy and n. So I treat this quantity. It is necessary to understand for what class of all the EOM should hold in order for the requirements of n to be valid. But today I treat only this quantity. And I comment k equal infinity singularity plays the same role as singularity at k equals 0 in n and e. This is because correlator with an arbitrary width on cylinder is invariant under the this inversion transformation. And this is keeping KBC algebra and changes the k equals 0 and k equals infinity. We introduce also k equal infinity regularization, but I don't introduce the new regularization. We introduce k plus epsilon regularization mapped to k equal infinity by inversion. So both singularity regularize at k epsilon eta k b c this. And the eta is regularized parameter at k equal infinity, and epsilon is regularized parameter at k equal 0. But today I omit k equal infinity correspondence. So we consider only k equals 0 singularity. And comment the theorem. This theorem is possible to show that the regularized version hold valid. And the KN and the EOM test is written as breaking order 1, order epsilon and order eta, order epsilon, order eta, and like this function. And this function shows that epsilon g 1 over k equal f g. This is also. So N and EOM test is invariant under this inversion symmetry. So return to the main subject. We consider zk and aijk in psi as a function which have poles zeros in the left half of complex plane like this. We assume if G and A has the zeros and poles on right hand side in complex plane, this is not possible because not ensure the inverse Laplace transformation. And for simplicity, we only consider the pole and the zeros on imaginary axis only 0. So alpha 0 and beta 0 equals 0, and other zeros or poles is left hand side. Then we can obtain the concrete expression of N and EOM for strong sense EOM. This is many terms, but we can write this simple form. And N equal to, this is, we consider from here after N is integer. So this is integer part, and this A and B is not integer, this function. Hypergeometric function, and this A and B equals 0 only, and 0 equals 0 plus minus 1. If not so, this is not equal to 0 and not equal to integer. So this is anomaly, valid broken integer and broken EOM test, and adding the new term. This is obtained in the case of m equal 1. And this blue part is determined only large G, large GK. But this thing term is determined by large G and off-diagonal part. And the W is given by this. And this is 0 or same anomaly, but multiplied G and B is a coefficient of this. Or this complex expression. And this is a case to separate. Delta n is determined as this. And if delta n larger than 0, this is naively divergent because the epsilon to 0 and this is epsilon 1 over epsilon. But if this term is divergent, it is possible sum is finite. So this is also okay. But hereafter, I consider only this case. I choose this. I choose large G and Aij satisfied this case. So then Karen and tau is written by integer part and anomaly part, and the same anomaly function and the same B function. This is simple form. And where they are, so simple form. And sorry. In the case of m equal 1, only one term, anomaly cannot avoid. So we can construct only plus minus 1 and 0, plus minus 2. But in this case, we can cancellation this red terms, between red terms. For example, this is a concrete example. So m equal to 2 terms. We use 2 terms. We can choose 3 degrees of freedom, large G and AII, A11 and A12, for example. And the condition delta n equals 0 and the definition G equal 1 minus trace. Demand n0 equal n11 and n22 equal 0. So this term equals 0 and this term equals 0 is solved as this. If n is 0 equal to n12 equal 1, and this coefficient is minus 1, and n0 minus 2, these are 3 solutions, and n0 larger than 3, no candidate, this solution. Next, we consider large m equals 3. Of course, I omit the k equal infinity contribution. So this is twice. Infinity contribution is the same as k equals 0. So we can construct 4 to 1, 2, 3, 4. Carry n. And in the case of m equals 3, we have 5 degrees of freedom, but we cannot choose the satisfy 3 condition. So carry n is sum over this, but all term is all term. We cannot choose all term is finite because this definition. So if n0 equals 0, and for example, n11 and n22 equal n0, and n3 equal 0. So we can use 2 terms Originally, we have 3 terms, but we cannot use all terms, so okay, only 2 terms. And in the case of n1 equal n0 and n2 is n0 to plus 1 larger than 1. This is originally we have 3 terms, but we can use 1 term. So this is a case same as m equal 2 case. So this is, in this case we can create the solution only plus 1 and plus 2, or minus 1 and minus 2. But this case, there is many degree of freedom, and the EOM is the same as A change to B. So we have enough degree of freedom and satisfy the condition. This is this. So we can construct winding number with arbitrary injected value, satisfies EOM strong sense if we prepare at least m equals 3. If m equal 4, 5, 6, 10 is same way, so we can construct any number of integer value. If n0 negative, we can we only this is we cannot n0 negative is same as this. So in the case of large m equal 1, 2, m is a number of term. Carry n can be limited to integer by EOM against psi itself alone, and there are only a finite number can be made. Whereas in general M, an infinite number of n with integer value can be created. And I don't say that winding number with no integer value do not exist yet. But I use SZ calculation. SZ calculation is which k extended complex plane. But for example, n is fractal. It is necessary to handle the path of Z integration carefully because the cut exists. So maybe we cannot obtain the fractal number of n, but I not completely understand. And it is necessary, and L invariant. This is a cross-string coupling with string field. Our psi is this. This is the same as m equal 1. So the equality between char n and L invariant, this is both is energy. Demand integer valued only. Like their theorem. So I don't know completely, but L invariant is given by only integer part. And this, okay. And recently, Hata-san construct multiple brane solution. I comment on the relation. He also confirmed energy and EOM for strong sense. So condition is same. The solution corresponds the case of m equal infinity in our context. He used infinite terms, except carry n equal 2. For carry n equal 2, one of our solution is equivalent to him, but the other solution is not equivalent. But he consider reality condition, and I don't consider reality condition. So this is a future work of relationship between our solution and Hata-san's solution. And first, I mentioned the boundary integration. This total derivative can be written as a boundary integration. This is Simon's theory. Ker n can be written as a boundary integration. This is the question. Roughly speaking, we have seen k equals 0 singularity and k equals infinity singularity only corresponding to n. And k is generate strips, and S is a total width of correlator. And this is proper time, and this is Hamiltonian. So k equals 0 corresponds to infinite time, and k equals infinity corresponds to time 0. So n is surface boundary of S. Indeed, if this quantity calculated by before S integration and K integration, we integrated to U. This is like this form in terms of S calculation. So maybe I can consider boundary integration. This is future work. So thank you. Finish.
You mentioned the quantity carry n should be integer.
Yes.
I don't think so because if we consider arbitrary solutions, that quantity corresponds to the distal amplitude of bounded homomorphic theory corresponds to some solutions. How do you think about this difference?
You mean outside of the universal section?
No solutions, the bucket energy.
No, but she's using only universal section.
Yeah. But I only KBC sector, but yeah. Yeah.
So what is the meaning of that integer? What is the interpretation of that integer?
Integer for carry n over 2 pi open string coupling square. Yeah. Energy. We consider energy is action value action when psi solution is static, and this is in this case, and this is tension of D brane. So carry n is number of D brane. But if so, our construction is not to distinguish plus minus. So negative number is I don't know how to treat negative ghost brane.
Almost pure gauge configuration. Start the equation motion, and then n comes naturally out of the number of branes corresponding to this solution.
Yeah.
And the target space is flat. Euclidean space. The target space is flat.
But yeah, I only target space left. but sorry.
How you're going to see Champagne factors emerging on the fluctuations?
Champagne factor include also. Okay.
These are solutions for multiple branes, right?
Yeah.
So if you analyze the fluctuations on them,
Mm-hmm.
you should be able to see UN's gauge symmetry coming out. You should
Okay.
be able to see that fluctuation organized as itself in n times n blocks.
Mm-hmm.
So I was wondering if you have thought about that.
I don't study with Champagne factor, but yeah, I consider it.
One more question
Yeah.
regarding the equation of motion. As far as I understand from the paper that you wrote by Kihata in 2019,
Yeah.
I think he didn't prove the equation of motion on this sense, like that it would be satisfied and contracted against four states. I think the other one is still there. And so have you done something in this direction?
I don't carry for EOM for Fox state. I don't calculate for Fox state, so I don't know satisfy for Fox state. But Fox state is natural state on the non-perturbative vacuum. So if not satisfy for the Fox state, this is I don't know how and so yeah, of course it is necessary to understand for what class of O the EOM should hold in order for the requirements. But Fox space is appropriate or not, I don't understand. And yeah, Hatta-san is not to consider Fox space for Fox space. I don't